Assalamu alaikum. Today we're gonna cover our third experiment, which is considered one of the most important experiments. So be focused, try to understand the basic idea for today's experiment in order to continue in the course without any problem. So this is our outline. First we're gonna talk about our objective, what we're gonna expect after finishing this experiment. Then we're gonna talk very briefly about Ohm's law, how the voltage and resistor and current are relating to each other, and how to find them. Then we're gonna move to look how the voltage is acting in any circuit. If you have a circuit parallel circuit, or if you have series circuit, how to find the voltage in such a circuit. Then we're gonna talk about special rules to find the voltage in a given circuit. The first one is VDR, which is voltage divider rule. The second one is Kirchhoff voltage law, KVL. Then we're gonna go to do the experiment and what the result that we expect to have from this experiment. So our objective from this experiment, first of all, to understand Ohm's law, how the voltage and current and resistor are relating to each other. Then we're gonna compare the voltage, how it's distributed in a series circuit or in parallel circuit. So we're gonna have a key idea about different connection for the voltage. Then we're gonna learn how to find the voltage in any circuit. So if you given a different configuration of resistor connected in series or parallel or in combination, then we're gonna talk about how to find the voltage in such a circuit. Also, we're gonna learn how to apply VDR and KVL, and most importantly in the practical part is to be familiar with the power supply, how to connect it in circuit, and we're gonna learn how to use the multimeter to measure the voltage, and in which case we call it voltmeter. So this is what we expect after we finish our experiment. So Ohm's law basically is the law relating the voltage and current and resistor together. So if you recall in the first experiment, we talk a little bit about electrical system. It consists of three elements: voltage, current, resistor, and we define each one separately, and we learn the unit for each one. So the voltage we measure it by volt, the current we measure it by ampere, and resistor we cover it by, or we measure it by ohm. And this is already we talk about it too much about the resistor, and we found that how to find the resistor values if it is connected in different way, and we deal with the resistor in the previous two experiments. So today we're gonna combine these three together, and we're gonna learn how to find one if you given two. So for example, if I give you the current and resistor, how to find the voltage? Just cover the voltage in this triangle by your hand, and this is the relation that we're gonna have. So the one at the above should be at the numerator, and the one at the below should be in the numerator, or they having multiplication relation. So to find the voltage, just cover it, and this is what you get: I multiply by R. If you're given voltage and resistors, then you have to divide V voltage divided by R. If you're given the resistor, if you know the voltage and the current for a resistor and you want to know its value, then just cover the resistor to find the relation that will help you to find the resistor. So this is the basic triangle that you have to know in order to find the desired quantity based on your given information. So if you're given voltage, current, then in this case you are able to find the resistor by looking at this triangle. It's very straightforward, it's very simple, as long as you understand this triangle and how to find what you want. So let's have an example to illustrate this idea. So given this simple circuit, so as you can see, this circuit consists of the three elements: voltage, resistor, and current. But you can see that it only gives me the voltage value and the resistor, and he asked me to find the current. How to find the current given to me this information? You just go back to see the triangle. I have the voltage, I have the resistor. What's the relation that gonna apply to find the current? If you go back to look for the relation, you're gonna see that you're gonna divide the voltage by resistor. So this is 10 divided by 5, and this is obviously 2 ampere. Be careful once you want to calculate with the units. If you have kilo, milli, then you have to do the right conversion. So this is basically about Ohm's law. In theory, it's very simple, straightforward. As long as you know two quantity, you can find the third one by looking for the triangle. Now let's talk a little bit about the voltage, how it's acting in a circuit. So if you have pure parallel circuit, what we mean by pure parallel circuit, all the resistors connected in parallel, no other element are interfering between two resistors. So as illustrated previously, to have parallel connection, you have to look for your resistor, they are meeting in 2 points and no other element sharing with them. If that's so happen, then in this case I can call this two resistor in parallel. Similarly for this two, and overall I can say that all the resistors here are connected in parallel. Then this circuit is pure parallel circuit. And in this case, if I look for the voltage across each resistor, we have a key idea that you have to put in mind once you have know this information. So if you have parallel circuit, the voltage across each element or each resistor is the same. So anything connected in parallel, the voltage is gonna be the same. And we're gonna talk here about the resistor, and this is what you know when you have the voltage. So if you have 10 volts here and they ask you to find the voltage across R1, directly it's gonna be 10. It's because they are connected in parallel. They're sharing the terminal of the battery or the power supply. Okay, and you're gonna have the same polarity of the voltage source. So the polarity here positive negative, then you're gonna have the same polarity positive negative. Okay, what about if you're having a series circuit or pure series circuit? What do you mean by series circuit? Again, each two resistors are meeting in one node or in one junction, and no other element sharing in this junction. If this is happen, then I can consider this connection as series. If you look for the resistor across each, if you look for the voltage across each resistor, you're gonna find that each resistor have separate and different value depending on the value of the resistor. So this is the idea that you have to put in mind. You have different voltage across each resistor based in depending on the value of the resistor. So if you have 10 here, you don't have 10 across each one of them. This 10 we're gonna distribute among all the three resistors. I'm gonna talk about a little bit a few rules or law that will gonna help us to find the voltage if you given a total voltage or a source voltage it was known for you. So the first special law, which is voltage divider rule, this is only applicable for series circuit, since as we agree for series circuit we're gonna have different voltage. In this case we're gonna apply this formula to find the voltage across each resistor. What you have to know to find the voltage, you have to know the resistor value and you have to know the total resistor value for all the resistor you have in connected in series. So you have to emphasize on series connection. If you don't have series, you cannot apply this formula. So also you need to know the total voltage that you supply your circuit. So knowing these two information, I can apply this information to find the voltage across each resistor. So X here is represent the resistor that you want to find the voltage across on. So if I ask you find V1, so just replace X here and X here. So we're gonna be the as follow: V1 equal R1 divided by R total multiplied by P source. So this is very straightforward formula, very easy as long you have a pure series circuit. This is not applicable if you have a resistor in parallel. You have to draw your circuit in series. If you have to use this formula only for series circuit. Obviously, for the R total or the total resistor, we talked about it in the previous experiment. For series circuit, you just sum up the resistor value together. So in this example, he asked me to find the voltage across R1 and R3. How to do that? First of all, you have to look for your circuit in which way it's connected. Obviously, that you can see that they are in series, since each resistor here are meeting in single point, and these two are single point, and the whole circuit are connected as one line. So you have overall this circuit is pure series circuit. This is your voltage source Vs or E in this example. So don't be confused with the letter. Some books use E as voltage source, some books use Vs in order to represent the voltage source value, but they having the same idea. So he asked me to find V1, V2. So you can see that the polarity has the same, polarity of the source. So how to find V1? First of all, I have to find the R total, which is basically the summation, and it's equal to 15. And to find V1, just apply the VDR. So R1 divided by R2, R total multiplied by V source. This is what we wrote in the previous exam slide. But here in this book, he used it in different notation. So he take the voltage source divided by R total, then multiplied by R1. Mathematically, they are doing the same, so don't be confused about it. So R1 2k ohm and R total 15k ohm. We found it, and the source 45, and this is V1. So voltage across R1 is 6 volt. Similar way for V3, you only need to replace the resistor value, which is 8, and you can see that is equal to 24. So you can see that for this circuit, each resistor have different voltage because they are connected in series, and this is the one way to find the voltage. So V1 is 6 and V3 is 24. Okay, what about R2? How to find it? You can apply the same formula, and you can see that's equal to 15 volt. This is the right answer if you want to find V2 by yourself. We're gonna talk about another formula in the next slide, which is more related to the series circuit also, to find the V1, V2, V3, or you're gonna it's gonna help us to find the missing voltage. If you don't want to apply the voltage divider rule to find R2, then you're gonna use different formula to find the missing voltage. So this law says it's named Kirchhoff voltage law, which is basically he says that for a circuit the sum of all voltage is 0 in one loop. What do you mean by one loop? If you have a series connection or one line or one complete circuit, and you follow the current flow in this circuit, then in this case I'm gonna have loop. So I'm start from one point and go back to end at the same point. In this case I'm gonna have loop, and this law says the voltage across each element in this loop, we're gonna equal the sum of it is gonna equal to 0 with the source that you have. So it doesn't talk only for the resistor, it also talk about voltage or any kind of element that you're gonna have in your circuit. So for a given circuit, the summation of the voltage in a loop is gonna equal to 0. To find or to apply this law to find the missing voltage, you need to know, or you have to assign the polarity of each element. So if you recall about the voltage source, the long line is the positive and the short line is the negative. This is fixed. So if it doesn't appear in your circuit, you have to assign it by yourself, positive, negative. The voltage will gonna follow the current direction, or in other way, the first terminal we're gonna connect it, the first sign of the resistor gonna be the same as the voltage that you have, the polarity of the voltage that voltage source you have. So you can see that at this node they are connected with the positive. So this should be the positive terminal of the voltage across this resistor, and the negative is gonna be at the second terminal, second end of the resistor. And I'm gonna follow the same order for the resistor. So positive, negative, based on the first connection. This is one way. And the other way, you have to look for the current direction. The current direction most of the time goes from positive to negative. So anytime you get inside an element, you have to look for the current direction. The current starts from positive and go back to negative. Similar way of the loop that you assign. So this is the current goes like this. So that's why this should be positive, negative. Should be positive, negative, and this is fixed. This is the only thing it's fixed, and it should be written as positive for the long line, negative for the short line. So how to apply KVL in order to find the voltage across each element in the circuit? First of all, you have to assign your loop direction. So the loop doesn't have to be like the same direction of the current, but if you do it, it's okay. So you have to assign the direction of the loop. Is it now clockwise مع عقارب الساعة? You can do it as counterclockwise عكس عقارب الساعة. But let's try to follow up how to apply this formula. So start from which element that you want. Let's start from the voltage source. Then you have to look for the arrow of the loop. The loop the first sign it sees once you get inside this voltage source is negative. So I have to write the negative for Vs. Then I go for the next element. What's the first sign I saw here? Positive. So I'm gonna write positive phi R1, the voltage across R1. So remember that I'm here only talking about voltage. I don't care about the resistor value. I don't care about the current. I'm only concerned about the voltage. For the second element here, or the third one, the first sign for this loop direction is gonna see first positive. So then I'm gonna have positive VR2, and Kirchhoff said that the summation of this voltage is gonna equal to 0. So this is basically what how to apply Kirchhoff law. And in few words, I can say that the supplied voltage is gonna be distributed among all the elements that connected in one line or one sharing one loop, or I can say that for a pure circuit, the summation of all the elements is gonna be the voltage source is gonna distribute it among all the elements in your series circuit. So this is what Kirchhoff say in a very simple way. So either you look at it as one loop, which is the most common case if you have one loop and no other elements connected in this circuit. The summation across each element in this loop is gonna equal to 0. So let's have this example. Although this is more theoretical, you can see that I'm having two voltage source. The first one 16 volt, the second one 9 volt, and I have the voltage value across this resistor. He asked me to find the voltage across R1. How to do that? Again, first of all, you have to know the positive negative terminal for your element. So this is long, should be positive here, long positive here. For the resistor, follow the first power supply or voltage source with the resistor. So positive connected with this element in this direction, so this should be positive. Most of the time I go with the highest voltage source. That's why I'm gonna force the volt R1 to be positive here, negative here, and this is we're gonna follow the same as the previous resistor. So this is the way how to assign the voltage if it is not assigned for you. Then you have to assign the loop direction. So in this example he chose counterclockwise, but let's try to do it in the clockwise as we do it in the previous way. So I'm gonna do it in green. So this is my arrow, and I'm gonna start to see what's the first element, what's the sign it sees first. It's gonna see negative, so you're gonna write minus E1. Then I go here and follow the arrow. The arrow is gonna look like this, and it sees first the positive sign for V1. Then this is positive V1. After that, the arrow it sees first for this element the positive sign, so I'm gonna have V2, positive V2. And for the third element, it sees positive, since the arrow is gonna be like this, so you're gonna write positive E2, and the summation of all this voltage is 0. If you replace the number, you're gonna have the same relation here, and this is the voltage value for for V1. In this example, he solved it in different way. You can look at it, but this is what we agree on. You have to assign your loop direction, and you have to see what's the sign it sees first before it's entering the element. So before I'm entering the element here, I see negative, I just write negative. Before I'm entering R1, I saw positive, and so on. If you go in this direction, if you go in the other way, you can see the same way. So if you go in the red one, so let's go with the red one. You can start from which element that you want. Let's say this one I'm gonna start with the first element minus, the second element minus, and here positive, and the summation gonna be 0. And obviously you're gonna see having the same answer. This book is following different technique. You can, if you're comfortable with it, or you're comfortable with what you learn in the theory, you can follow what you want. I don't ask you strictly to apply this technique that I learned teach you here. I only want to state what Kirchhoff voltage law and how to apply it. So basically, Kirchhoff voltage law, for a given loop, the summation of the voltage is 0. And this is mostly applicable for only series circuit. If you have parallel, then you're gonna have 2 loop, and Kirchhoff gonna apply only for 1 loop. So we're gonna apply Kirchhoff for the first loop, apply Kirchhoff for the second loop, but this is another topic that we don't talk about in this experiment, or today's experiment. So moving on, in example to find the voltage. So if you give in this circuit how to find the voltage across R1, R2, R3, basically you can see that I have pure series circuit, and I'm gonna easily find the voltage by applying VDR, voltage divider rule. How to apply VDR? You have to find R total, which is here the summation of the resistor. Then I can apply VDR V1 equal R1 divided by R total multiplied by voltage source, and this is V1. Similarly for V2, find V2. Similarly V3. So since I'm having pure series circuit, I can apply VDR to find the voltage across each resistor. The second example here, it's very easy, very straightforward, as long as you know and understand the idea of the voltage, how this does distribute in parallel and series. So obviously I'm having here pure parallel circuit. What I mean by pure, all the elements are connected in parallel. So in this case, the voltage across each resistor is gonna be same as the voltage connected in these two nodes. So since the power supply is connected to these two nodes at these two junction, since then this resistor gonna have the same voltage of the voltage source. So V1 equal V2 equal V3, and all of them equal the voltage source, which is 10 volts. It's very straightforward, as long as you saw that I'm having parallel connection and no element sharing in this connecting. So you have to put this in mind, because if you look at it in this example, so in this example you can see that I have parallel, but before this parallel I'm gonna have a resistor connected series with the voltage source. So in this case you cannot say that 10 the voltage for R2 is 10. This is wrong, because they are not connected parallel. They are not connected in parallel. I mean the R2 with the voltage source. So what you need to do, you have to convert this circuit in simpler one in order to find the voltage across across the resistors, and then you have to go back to original circuit to apply what you learn depending on the connection. So by looking for this circuit, what's the relation between R3 and R2? You can see that they are in parallel. So if I know the voltage across V2 or if the voltage across V3, then they're gonna have the same voltage. But V2 and V3 does not have the voltage value of the voltage source, since they are not connected with parallel with the voltage source. So be careful with that, put it in mind once you try to calculate. But you can put this in, you can put you can put the idea of that R2 and R3 in parallel. The equivalent of R2 and R3, they're gonna have the same voltage of R2 and R3. So I'm gonna find the equivalent, find its voltage, then I'm gonna go back to find V2 and V3. For R1, again I need to have series circuit to find the voltage, so that's why I'm gonna convert the circuit to this way. So I just apply parallel between R2 and R3 since they are connected in parallel, and convert it to a resistor called RB. So this is the new circuit, or this is what I saw in theory. I can take these two resistors as one resistor having this value, and by doing that and redrawing the circuit, you can see that I have here pure series circuit. Now I can apply VDR, since VDR only applicable for series circuit. So I find V1 by VDR. So what's the total resistor here? The summation between R1 and RB, not R2 or R3, the RB, because RB is the equivalent from R2 and R3. I just replace R2, R3 with RB. Okay, now apply VDR. I found V1, VB, but I don't want to have VB. I want to find V2 and V3. If you go back to the circuit, VB is actually the equivalent for the parallel from R2 and R3. And I know that if I know the equivalent voltage for a parallel connection, then it's gonna have the same voltage. So this is, since this is the one having a voltage since I know the voltage for this one, then based on the connection of these two, since they are in parallel, then I can say that they are having the same voltage. That's why I can say that VB is equal V2 equal V3, and this should be 3.3. If you try to look for the summation, you can see that 3.33 plus 6.77 is equal to the source. So this is another information you can put it in mind. Okay, let's have another example, different connection. So in this connection, what you can see, I am having R2, R1 are connected in series, and all of them are connected with parallel with R3. Okay, what about the voltage? Can I say that since they are in parallel, for R1, R2 having the same voltage of R source, the voltage source? No, because again, this is not purely parallel with the voltage source R1, because it shares the first terminal but does not share the second terminal. So you have to be careful about this. And similar way for R2, sharing this in a terminal but it's not sharing this terminal. That's why it have different value from the power supply. But okay, what about R3? If you look for the terminal, the first one connected to the power supply or the voltage source, and second terminal here, or the second end of this resistor connected with the negative. So in this case, this resistor have connected parallel with the voltage source, so it has the same voltage of the voltage source. Okay, what about R1 and R2? Again, I'm gonna convert it to one resistor, and I'm gonna find the voltage across this resistor and apply the VDR if I'm having series circuit. So what I did now, I just convert this two resistor as one resistor. I'm gonna have here pure parallel circuit. The voltage here is 10, the voltage here is 10. Now if I go back to my circuit, imagine that the summation of the voltage across these two resistors as should equal to 10, because RA, the equivalent resistor, gonna have the voltage of 10 since they are in parallel. If you go to apply VDR, so how to see that in VDR? You can redraw the circuit. You can draw the small circuit here, voltage source, so this is your new circuit. Why I can do that? Because I know the voltage source, I know the voltage I need to distribute among these two resistors in series. But since they are in series, they're gonna have different voltage, and I'm gonna apply VDR to find the voltage across each one. So this is the small circuit. This is imaginary one, R1, R2. Then I need to apply VDR for this small circuit. So basically R1 divided by, so be careful here, not R total, because R total is the if you want to convert the whole resistor into one resistor. Here I'm only concerning about these two resistors, which is I find it already to be RA. So VDR here gonna be applicable for RA, because the voltage I gonna take it from RA for VA, not voltage source, although they having the same voltage. But just to put in mind the procedure, you need to apply VDR for VA. The voltage you supply, or the one is related to the circuit that you have. So I'm going back from here to here, and I can redraw the circuit as this circuit. So this is VA, and the summation of these two resistors, I found it already, is equal to 4K, and this is what you need to apply. Be careful with this. You have to understand it very well in order to deal with the circuit and how to find the voltage across each one of them. Okay, now let's go to the practical, but before let's introduce to you the basic concept about the device, measurement device for the voltage, which is the voltmeter. So in any kind of circuit, in order to do the measurement, you have two ways to connection. Either you just connect it parallel with the resistor, or you connect it series with the resistor, as we're gonna see in the next experiment. So this is the only way to connect your multimeter. This is so this is the circuit. I want to measure the voltage across the resistor. Either you connect it in parallel or you connect it in series. But which way is the correct way? In order to know it, we have some information about the voltage or the voltmeter. It says that the resistor of the voltmeter is high. So this is already built in the multimeter. Once you try to measure the voltage, or you're gonna use the voltmeter, you have to put in mind it has a very huge resistor. If you recall from the first experiment about the conductivity, or the conductor and the insulator, and the definition of resistor, if you have huge resistor, it means that the element here is gonna represent it as open circuit. So if you look back from the definition of the high resistor, it means that I'm gonna have open circuit. So this is what we mean by having high resistor. It's basically I'm have open circuit, no connection. And the similar way here. Obviously you can see that the right connection this way, because the circuit is complete. I'm taking the measurement without interfering with the value of my circuit. While here, if you connect in this way, you're gonna have a not complete circuit. Your measurement is gonna interfering with the circuit. So don't connect it in series. You have to connect it in parallel. So for measuring the voltage, we need to connect the voltmeter with the resistor in parallel, as we saw, or as we're gonna see in the experiment. So you can see the experiment for this video. I explained in detail. Try to follow the instruction there. If you have any question, maybe you can ask me in the lab. What I'm gonna ask you before you come to the lab, try to do it by yourself. I'm gonna apply some question in the pre-lab, depending for the same example here. I ask you to find the voltage across one of the resistor. But by the end of the day, you need to know how to find the voltage V1, V2, V3, as I explained in the previous slides. So what we're gonna do in the lab, before you come in the lab, you have to calculate the value for V1, V2, V3 by applying VDR, or knowing that for parallel it has the same voltage. So you try to apply the right formula to find the voltage across each resistor. Then once you come to the lab, try to measure each voltage. First you have to connect with the power supply and complete the circuit. Then you have to measure the voltage for each resistor, and it must have the same value of the calculated. So we have 4 circuits. If you have time, you're gonna cover it all of them. Okay, see you next time.